Welcome back to our Spark learning session. Today I'll be going through exercise for trees. We'll be learning trees today. To learn trees, we'll go through the documentation example that goes through different trees such as decision trees, random forest trees, and green bushes trees. So let's get started and dive into our project. For that, let's start with importing the necessary libraries for our project. Let's run this and let's run this as well. Let's start our Spark session for our project. Spark equal to Spark session builder dot app name and tree teach. Getter create. Let's run this as well. Next, let's get the input data that we need for our project, and that's going to be in a libsim format. libsvm format, and I'll copy rest from my other screen so that I won't make any mistakes and save some time. Let's run this. Input read. It should be input read. Now let's look at what's inside input data. Can you guess what's inside it? Let me show you. Input data dot show is a libsvm format data, so you will see labels and some other information such as feature vectors and number of the data and number of rows, number of records in feature vectors. Input data is not defined. It says, let me correct that and let's make sure that it is there. Now it's trying to print out what's inside this data. In the meantime, let's move ahead and write some other code that will split the data into test and train data. Test data and test data equal to, we'll divide the sample data into random split by doing random split into 70-30%. 70% will be a training data while 30% will be a test data. Did that? Let's see. There you go. Now let's go back to our previous statement where we have input data and we have samples input data. First column is label, it's a category values, and second is 692. And that's how many feature vectors are there in this features column. In this exercise, we are only concerned about doing categorical classification than regression analysis because of scope of our project. If you are interested, then you can go to website of PySpark and do yourself the regression analysis. Now let's start with initializing some models. DTC for decision tree classifier Second is going to be RFC, random forest classifier, and it's going to be number of trees should be around 100. DBT should be around ZBT classifier. Now let me start with let me start fitting the model to the training data set. It's going to be DTC fitted model and DTC dot fit. It should be training data set we are trying to fit for. It works. And let's do for RFC fitted model and do similar for DTC. It's going to be RFC. Instead DTC is going to be RFC. Now we'll do for gradient boosted trees. Can you guess what it should be? Let me show you. Gradient boosted trees fitted model ZBT dot fit train data. Now we have fitted the model for training data. We need to use this model to get results, prediction results from the test data. For that, we'll do DTC dot test result equal to similarly RFC test result equal to ZBT test result equal to. Let me just write it down. Okay, now it should be fitted model. DT should be DTC fitted model and RBC should be RBC fitted model and GBT should be GBT fitted model. And inside we are using transform data as our function to get the result what we need. And result should be, we are targeting the test data for our purpose. Let's target the test data. And now we have run this program. Let's see what's inside these test results. We have these columns: label, features, raw prediction, probability predictions. Similarly, let's do for RFC. What we get? We have label, features, raw prediction, probability, and predictions. Now we're going to do for DTC. ZBT. Let's do for ZBT. Can you guess what it will show? Let me show you. It's similar data as we saw earlier. Now, next step is to evaluate our prediction results using multi-classification evaluator. We'll use the metric name accuracy to evaluate our functions, evaluate our models. Accuracy.eval should be equal to multi-classification eval. We are initializing this evaluator with metric name equal to accuracy. Metric name should be equal to accuracy. Now we'll see how does these three stack up against each other. Let's start with the DTC result. And we'll take this accuracy eval dot evaluate DTC test result and evaluate that using multi-classification evaluator. Let's do that. Let's see what we get. 96% accurate. A 96% accurate. Secondly, I'll be working on RFC. That's 100% accurate. And thirdly, GBT. That's 96% accurate. So it seems RFC is more accurate than other two. Now we'll be looking at the importance of features within each model. Let's take fitted model. Let's take the DTC model, and secondly we'll look at RFC fitted model, and lastly we'll take a look at GBT model, and let's look at feature importances. In the DTC model, it seems feature number 100 is the most important, feature number 406 is the most important one, and in RFC model, there are so many features here and it's hard to see which one is most important. And for last one, let's see what we have here. It seems the most important one is feature number 406. In the end, let me quickly summarize what we discussed today. We use the libsvm data to classify data into different classes. To classify data, we use decision tree classifier, random forest classifier, and GBT classifier. We took data and divided that into training and testing data. Once we have the initialized model, we train the model on the training data, and we use that fitted model to get the result, prediction result on the test data. Then we use a multi-classification evaluator to evaluate the results using accuracy as our metric. And then lastly, we use the feature called feature importance in fitted model to see which feature played most important role in evaluating the data. So that's all for today. I will see you next learning session. Thank you so much.